What if I told you that there are doors in the universe that could connect you to other places and moments in time? Wormholes, those fascinating mysteries of modern physics, invite us to delve into a world where logic and imagination intertwine in surprising ways. Since their theoretical discovery, they have captured the attention of scientists and dreamers alike, challenging our understanding of reality. Wormholes, in essence, are shortcuts through space-time. Imagine the universe as a sheet of paper. If you fold that sheet, the ends could touch, allowing something that starts at one point to end at another almost instantaneously. But do these connections really exist? Could they be more than just simple mathematical concepts? The truth is that science is still trying to unravel this intriguing phenomenon. One of the most fascinating questions that arises is, can wormholes be stable? Current physics tells us that upon formation they would collapse almost immediately. This creates a dilemma. If wormholes are so unstable, how could we use them? And despite the uncertainty, the idea that they could allow us to travel instantaneously through the cosmos or even through time remains a spark that ignites our curiosity. But that's not all. To keep a wormhole open, it is believed that we would need something called negative energy. Can you imagine what this means? Enormous amounts of energy that we still cannot comprehend or produce. Is it possible that in the vast universe there is something that can sustain these structures? The search for this mysterious energy takes us into uncharted territory where science and speculation meet. Furthermore, another question arises. Have wormholes formed naturally in the cosmos? Wormholes are fascinating, but their stability is a real puzzle. Why do scientists believe they would collapse almost instantaneously upon formation? To understand this, we must first imagine how they behave according to the laws of physics that we know. Wormholes, those interdimensional doors that promise to connect different points in space and time, are conceptually intriguing, but their existence poses a series of challenges. Let's take a moment to consider what it means for a wormhole to be stable. If a wormhole were to form at this very moment, could we cross it without issues? The reality, according to theorists, is that the instability of these phenomena could be their greatest obstacle. Essentially, it is believed that any attempt to keep a wormhole open would be a monumental challenge. What forces or conditions could keep it standing without collapsing in an instant? For a wormhole to remain open, physics suggests that we would need a very special type of energy known as negative energy. But what exactly is negative energy, and why is it so crucial for the stability of these mysterious tunnels? In simple terms, negative energy refers to a form of energy that counteracts gravity. Imagine a force that pushes outward instead of pulling inward. However, another intriguing question arises. Does this negative energy really exist? And can we obtain it in any way? The quest for negative energy leads us to an even deeper dilemma. If wormholes collapse so quickly, is there any hope that we could create one artificially? The answer seems to be an enigma. As while theory tells us it is possible, the necessary conditions are so extreme that they are beyond our current understanding. Could we, at some point with advancements in technology, develop a way to manipulate negative energy to keep a wormhole open? Now imagine we find a wormhole that has formed naturally. Could we take advantage of it? This is where the dilemma becomes even more complicated. If wormholes are so unstable, would it be safe to attempt to cross them? The very nature of their existence raises questions about the safety of such a journey. Moreover, if they are merely a mathematical construct, can we really trust that they will ever be anything more than a theoretical fascination? Many of you may wonder if there is any evidence that wormholes actually exist. Despite decades of study, the answer remains no. However, scientists do not give up. There are theories and models that suggest that, despite their instability, they could be present in the cosmos, waiting to be discovered. But what good would a wormhole be if we cannot use it? The idea of wormholes is seductive, but their stability is a mystery that blurs the line between science and science fiction. Each new discovery in the field of physics leads us to question what we think we know about the universe. Are we one step closer to understanding the true nature of wormholes, or are we delving into a labyrinth with no exit? As we delve deeper into these questions, we can see that the stability of wormholes is an issue that requires more than just theories. We need a new way of thinking about time, space, and energy. What if the future of space exploration depends on our ability to solve this dilemma? The possibility that one day we could travel through wormholes remains a dream, but with each new generation of scientists, perhaps we are closer to unraveling this mystery. Research on wormholes invites us to question not only what we know, but also what we have yet to discover. Each answer generates new questions, and each discovery becomes a doorway to a new world of possibilities. What if wormholes are the key to understanding not only our universe but others beyond our own? There is no doubt that wormholes represent one of the greatest challenges of modern physics. As scientists continue to explore this fascinating field, we may come closer to a deeper understanding of how the cosmos works. Could wormholes become the bridge that connects our current understanding with the secrets of the universe? As we immerse ourselves in this mystery, let us remember that science is a constantly evolving journey. The quest for the stability of wormholes is a clear example of how knowledge develops and expands. Each new finding brings us a little closer to understanding the vastness of the cosmos and our place within it. Who knows, perhaps one day what seems impossible today will become our reality. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. What if I told you that to keep a wormhole open, we would need something that science still doesn't fully understand? That is the reality we face when we talk about the mystery of negative energy. But what exactly is negative energy? In simple terms, imagine an energy that is not only scarce, but also acts in a way that is contrary to the positive energy we know. This idea may sound like it's straight out of a science fiction novel, but it has its roots in theoretical physics. To understand this concept, let's think about an everyday example. When we talk about positive energy, we refer to things that give us a boost, like sunlight or electrical energy. Now, negative energy would be like a vacuum that instead of filling spaces sinks them. But why do we need this negative energy for a wormhole? Because, according to current theories, a wormhole is a tunnel in the fabric of space-time that could connect two distant points in the universe. However, for this tunnel to remain open and not collapse in an instant, enormous amounts of that negative energy would be required. Now, where could this negative energy come from? Scientists have proposed various theories. Although none have been proven, some suggest it could arise from certain quantum phenomena, while others point to the possibility that there may be a form of matter that we have yet to discover. Imagining that there is something in the universe that could act as a support for these wormholes is both fascinating and perplexing. But does it really exist? In the world of physics, negative energy also leads us to the question of whether wormholes are merely a mathematical construct. If we consider that they can be described and predicted using equations, does that mean they actually exist in the universe? The answer is a resounding maybe. Mathematics is a powerful tool for understanding the universe, but it doesn't always translate into physical reality. Thus, we find ourselves at a point where theory and practice seem to clash. Imagine there were a wormhole in our own solar system. How would we detect it? The answer is that so far we have found no evidence that they exist. The search for these subatomic phenomena resembles the quest for the Holy Grail in physics. Some believe that by observing certain patterns in gravity or anomalies in space, we might catch a glimpse of the existence of these cosmic tunnels. But what would the existence of wormholes really imply? The idea that we could travel instantaneously across the universe is tempting, but it also raises unsettling questions. If wormholes are real and we can traverse them, what would happen to time and space? We could find ourselves in a distant future or in a past that no longer exists. That is the dilemma we face, the possibility that a wormhole could be a gateway to another part of the cosmos or a pathway to chaos. As we delve deeper into this idea, we encounter an even greater enigma related to negative energy. Is it possible that negative energy is a fundamental property of the universe, a kind of balance in which even forces that seem negative have their place? String theory and quantum gravity have begun to explore these concepts, but we are far from reaching definitive conclusions, and this is where science becomes a game of patience and discovery, if we think about it. The search for negative energy to stabilize wormholes also leads us to question our understanding of matter itself. What kind of matter could have these strange properties? Some scientists suggest it could be a form of exotic matter that does not behave like the conventional matter we know. But how can we search for something we don't even know exists? In this maze of theories and concepts, it's easy to get lost, but each question brings us a little closer to understanding our universe. Negative energy is one of those pieces of the puzzle that, if we manage to fit it in, could open doors to new dimensions and realities. So the next time you think about wormholes, remember that there is a vast field of possibilities and mysteries yet to be discovered. The fascination with wormholes and their relationship to negative energy is not just a topic for scientists, it is an invitation to explore the limits of our imagination and knowledge. Every new discovery in the field of physics can change our view of the cosmos and perhaps one day lead us to find those tunnels in space that could connect not only places but also times and realities. In this journey into the unknown, every question is as important as the answer. Have natural wormholes formed in the vast cosmos, or are they merely an invention of the human mind and mathematics? This is an enigma that leads us to explore the limits of our understanding of the universe. The idea that these cosmic tunnels might exist, connecting different points in space and time, makes us reflect on the very nature of reality. Since time immemorial, scientists have speculated about the existence of structures that could allow for instantaneous travel through the cosmos. However, so far we have not found conclusive evidence supporting the existence of wormholes in our universe. But what if they really existed? What if, instead of being just a theoretical concept, they were part of the very fabric of the cosmos? Let's consider for a moment the vastness of the universe. There are billions of stars, and many of them could host planetary systems similar to ours. In this immense scenario, the possibility that wormholes could form naturally does not seem so far-fetched. But how could these structures arise? Would they form from extreme phenomena, such as the collision of neutron stars or the collapse of matter under extreme conditions? Einstein's general relativity predicts the existence of wormholes, but science has yet to identify one in practice. Could they be fleeting events that open and close in an instant, leaving only a trace of their existence? This idea raises more questions than answers. If they truly exist, why have we not been able to observe them? Is there something in our current technology that prevents us from detecting these mysteries of the universe? One of the most intriguing theories is that wormholes might not be visible in the way we imagine. Perhaps they hide behind phenomena we have already observed but have not been able to identify as such. Could it be that these structures exist in dimensions we do not yet understand? The universe is a mysterious place, and every day that passes, scientists discover more about its secrets. Let's think about the implications if wormholes were real. If they formed naturally, what would it mean for our understanding of intergalactic travel? Would it mean we could travel to other galaxies in a matter of minutes rather than millions of years? This concept is as thrilling as it is terrifying. Imagining that we could cross the universe in the blink of an eye leads us to consider the possibilities of life on other worlds. However, a troubling question also arises. If wormholes are portals connecting different parts of the universe, what about the dangers they might present? What if a wormhole formed near a black hole, creating a one-way trip? This dilemma adds a layer of complexity to the idea of wormholes as means of transportation. The theories about the natural formation of these wormholes also force us to consider the possibility that they exist in unexplored regions of the universe. Could they be found in areas where gravity is so intense that it challenges our current understanding of physics? The search for these mysteries could lead scientists to the frontiers of the cosmos, where the laws we know may not apply. As technology advances, so does our ability to observe the universe. More powerful telescopes and increasingly sophisticated space missions could open the door to detecting signals that suggest the existence of wormholes. But will it be enough, or is it possible that these structures remain forever hidden, elusive as a mirage in the desert? Some scientists believe we might find indirect evidence of wormholes through anomalies in gravity. Could these irregularities be echoes of the existence of these cosmic tunnels? The idea that we could detect something we cannot see is fascinating, reminding us that the universe has much more to offer than our senses can perceive. The search for wormholes also leads us to question our understanding of time and space. If these tunnels exist, could they be the key to connecting parallel realities or even unknown dimensions? The possibility that we could access other universes raises questions that blur the line between science and fiction. In conclusion, the enigma of wormholes and their possible natural formation remains one of the great mysteries of modern physics. As we continue to explore the cosmos, it is essential to keep an open mind to the unknown. Wormholes may be a theoretical concept, but their potential to change our understanding of the universe is immense. Who knows what discoveries await us in the vast darkness of space? Have you ever dreamed of being able to travel back in time? Imagine having the opportunity to return to those moments you wish to relive or even change. Would you like to visit the past, meet your ancestors, or witness historical events? The idea of wormholes, those mysterious tunnels in the fabric of space-time, could make all of this possible. However, there is a significant dilemma surrounding this fascinating idea. The problem of time travel. Wormholes, in theory, could connect 2 points in space and time, but what happens if you decide to traverse one? Could you really change the past? The simple idea of altering history raises unsettling questions. If you decide to prevent a tragic event from occurring, could you create a new timeline? Can you imagine the paradoxes that would arise? The famous grandfather paradox is a good example of this. If you travel to the past and prevent your grandfather from meeting your grandmother, how could you have existed to make that journey in the first place? This time travel dilemma becomes even more complicated when we consider that any small change could have enormous repercussions. A simple gesture that seems insignificant could alter the flow of time irreversibly. Are we prepared to bear that responsibility? Perhaps the possibility of traveling back in time should be considered with extreme caution. On the other hand, the idea that wormholes allow time travel leads us to question the laws of physics. Are these laws as rigid as we believe? If wormholes do indeed exist, could they be the key to unlocking the secrets of time? Some scientists think that while wormholes could be a doorway to the past, they could also be a pathway to the future. But do we really want to know what tomorrow holds? Time travel is not just a science fiction entertainment. Quantum physics suggests that time is not as linear as we perceive it. What if time is more like a vast ocean, where different currents can take us to different moments? This concept can be disconcerting, but it is also fascinating. If time is not a straight line but can be navigated like a river, what opportunities would open up before us? Imagine that instead of being a mere spectator of history, you could be an actor in it. You could learn from your mistakes, experience, and perhaps even improve your present. However, with each action, uncertainty arises. If every decision counts, what would be the impact of your choices? The responsibility of knowing the future could be overwhelming. And not only that, the implications of traveling through a wormhole lead us to the concept of multiple universes. What if by changing an event in the past, we created a new reality where things are completely different? Every decision could give rise to a new universe, a new path we never would have imagined. This leads us to wonder, how many versions of ourselves could exist in different realities? Of course, science has not yet provided definitive answers about the possibility of time travel. Most theories are speculative and often based on complex mathematical models. But that doesn't stop us from dreaming. Who hasn't wished for a DeLorean or a TARDIS to explore the past and the future? Popular culture has fueled our imagination about these possibilities, making time travel an even more appealing topic. Ultimately, the dilemma of time travel confronts us with the question about the nature of time itself. Is time a resource we can manipulate at will, or is it an unyielding current that we must follow? The answer to this question could change not only our understanding of the universe, but also our perception of ourselves. As we explore the depths of physics and the mysteries of the universe, we may never fully comprehend time travel. But that doesn't mean we shouldn't keep asking and exploring. After all, the true journey may be the knowledge we gain along the way. What would the past teach us if we had the chance to listen to it? So even though wormholes and time travel remain an enigma, they invite us to reflect on our existence and the impact of our decisions. Human curiosity never stops, and perhaps one day we will discover that time is not as rigid as it seems. Who knows what mysteries await in the shadows of space-time waiting to be revealed? When we think about the world of wormholes, intriguing questions arise about the very nature of reality. One of the most fascinating mysteries surrounding these phenomena is their connections to quantum mechanics. But what does this really mean? Quantum mechanics, the branch of physics that studies the smallest parts of the universe, suggests that particles do not always have a defined existence. In this context, we might ask ourselves, could wormholes appear and disappear in the blink of an eye? Imagine a world where wormholes are as ephemeral as a flash of light. Theories suggest that in the vacuum of space, these cosmic tunnels could constantly form and fade away. This leads us to a crucial question. If wormholes can arise from nothing, what does this imply for our understanding of time and space? Are we facing a reality where the limits of our existence are much more flexible than we believe? The idea that wormholes could be fleeting products of nature leads us to reflect on their stability. If they are destined to disappear so quickly, could it be that we will never see one in its complete form? Or perhaps they are only visible at very specific moments in time. This mystery envelops us in a labyrinth of possibilities. But what about their relationship with energy? Quantum mechanics tells us that particles can be in multiple states at once. If wormholes are the result of this quantum behavior, what kind of energy would we need to stabilize them? Could we even interact with them before they fade into nothingness? This raises another important enigma. If wormholes are so volatile, could they be used for something more than just shortcuts in space-time? In the quantum realm, even the notion of a vacuum becomes more complex. Instead of being an empty space, the quantum vacuum is filled with fluctuating energy and particles that appear and disappear in the blink of an eye. So, could wormholes be part of this sea of quantum activity? If so, we would be facing a phenomenon that transcends our ideas of what it means to exist. We cannot forget that quantum mechanics also suggests that, at the subatomic level, information can be transmitted instantaneously, challenging our notions of distance and time. This leads us to wonder, if wormholes are related to these quantum properties, could they be a form of communication across the universe, a means for information to travel beyond the limitations of space and time? In considering the connection between wormholes and quantum mechanics, we also encounter the paradox of observation. In quantum mechanics, the act of observing a particle can change its state. So, if we ever manage to observe a wormhole, could that alter its behavior? Would we be doomed to miss our chance to interact with them simply by trying to understand them? The mystery doesn't end there. Advances in quantum research have led to theories suggesting that quantum entanglement could play a fundamental role in the nature of wormholes. Could it be that these tunnels in space-time are connected through a quantum fabric of the universe? And what if each wormhole is in fact a thread that ties everything together in a vast network of interconnection? As we explore these ideas, we must also consider the impact of uncertainty. Quantum mechanics teaches us that the future is not predetermined and that multiple realities can coexist. Does this mean that wormholes could be portals to different versions of the same universe, or perhaps to completely distinct universes? The notion of multiple realities opens up a range of possibilities that challenge our understanding of existence. In the end, quantum mechanics and wormholes invite us to question what we know about reality. Could these phenomena be the key to unraveling the secrets of the cosmos? Or are they simply an illusion created by our inability to comprehend what lies beyond our perception? The search for answers to these questions continues, and each new discovery brings us a little closer to understanding the mystery of wormholes. Ultimately, the connection between wormholes and quantum mechanics is not only a fascinating topic but also challenges us to rethink what we consider to be the fundamental laws of the universe. Exploring these mysteries is not just a journey into the unknown, but also an invitation to expand our horizons and accept that perhaps reality is much stranger and more wonderful than we have ever imagined. The connection between black holes and wormholes is a topic that sparks curiosity among scientists and enthusiasts alike. Could these mysterious cosmic phenomena be related in some way? In the vastness of the universe, black holes are known for their powerful gravity, which prevents anything from escaping, not even light. But what if I told you that some theorists believe they could be connected to other points in the universe through wormholes? Imagine a black hole as a vortex in space-time, a kind of entryway to an unknown region. However, the idea that a black hole could be the end of a wormhole raises fascinating questions. What is on the other side? Some scientists suggest there could be a path to a different universe, or even to another part of our own universe. The possibility that these two phenomena are interrelated opens up a range of possibilities that challenge our current understanding of physics. But how does this connection work? In theory, a wormhole could act as a bridge, a shortcut through space and time. If we take a black hole, which absorbs all matter and energy around it, and connect it to a wormhole, we could be talking about a phenomenon that allows for instantaneous travel to another location. However, this also poses an intriguing dilemma. Would it be safe to traverse a wormhole that originates from a black hole? As we delve into this discussion, more questions arise. If wormholes really exist and are connected to black holes, could they be used for time travel? Some scientists believe this could offer a solution to the time paradoxes that have plagued physicists for decades. But are we really prepared to face the consequences of such travels? The implications of altering the past are profoundly complex. The theory also suggests that the interior of a wormhole could be a completely different place compared to the outside. Imagine a strange landscape where the rules of physics as we know them do not apply. This environment could be full of surprises, but also dangers. What would happen if, by traversing a wormhole, you found yourself in a place where the laws of nature are radically different? The idea of venturing into the unknown is both tempting and terrifying. Moreover, we must consider the role of exotic matter. For a wormhole to remain open and functional, a form of matter that we have yet to discover is required. This exotic matter would have unusual properties, such as negative energy, which could counteract the natural tendency of a wormhole to collapse. However, where could we find this matter? The search for answers leads us to explore the cosmos for clues. On the other hand, the connection between black holes and wormholes is not just a theoretical concept. There are mathematical models suggesting that these structures could be more common than we think. Some theories propose that each black hole could be linked to a wormhole, functioning as a portal to another location. But how can we verify these ideas? The lack of tangible evidence makes it difficult to validate these theories. Science is constantly advancing, and as we develop new technologies, new possibilities arise for investigating these mysteries. Space exploration, along with advancements in astronomy, may allow us to observe phenomena that support or challenge our current theories. The search for wormholes could be one of the keys to unraveling the secrets of the universe. In this context, it is also important to consider the philosophical implications of such discoveries. If wormholes connect different parts of the universe, what does this mean for our understanding of time and space? Could we be part of a multiverse where each wormhole is a doorway to an alternative world? These questions lead us to reflect on our own existence and the place we occupy in the cosmos. As science continues to advance, we must not lose sight of the fact that many of these concepts are still speculative. The connection between black holes and wormholes remains an active area of research, full of possibilities. Although we may not have definitive answers, the mere act of exploring these ideas brings us one step closer to understanding the nature of the universe. The quest for answers about wormholes and their relationship with black holes is not just a scientific journey, but also a journey of imagination. It serves as a reminder that while science seeks the truth, it often lies at the boundary between the known and the unknown. So as we continue to explore, let us keep an open mind and keep questioning. Who knows what discoveries await us in the vast and unexplored universe? Have you ever wondered how long a wormhole could remain open? This is a fascinating and in some ways perplexing question. The idea that we might have access to a shortcut through the universe, allowing us to travel instantly from one point to another, sounds exciting. However, the reality is that the duration of a wormhole's opening remains an enigma. But why is it so difficult to determine how long it could stay open? First, it is essential to understand that wormholes, if they exist, are extremely unstable structures. The theory suggests that they could open and close in an instant, as if they were doors leading to other corners of the cosmos. This raises a troubling question. If we manage to enter one, would we have enough time to exit before it closes? Imagine being in the middle of an intergalactic journey and finding yourself trapped inside a tunnel that is quickly closing. Scientists have speculated that even if a wormhole were to open, its opening time could be so brief that it would be unusable for travel. But what causes this instability? One of the most common theories suggests that the energy required to keep a wormhole open is so immense that it could not be sustained for long. This leads us to wonder, could there be any way to stabilize it so that it lasts longer? Imagine there is a way to keep a wormhole open for a longer time. What implications would this have? As scientists delve into the physics of these structures, they have begun to explore the idea of using exotic matter, a type of still unknown matter, which could help keep a wormhole open. But here arises another intriguing question. Is it possible that there are already sources of this matter in the universe that we are unaware of? The duration of a wormhole's opening also relates to its size. A tiny wormhole could close much faster than one of considerable dimensions. This leads us to think, could there be wormholes on such large scales that their openings could last long enough to allow the passage of spacecraft? Imagination runs wild at the possibility that advanced civilizations, which might have mastered this technology, have found ways to stabilize and effectively use these portals. However, even with these theories, uncertainty persists. Studies on wormholes have shown that time can be a very complicated factor in this context. General relativity tells us that time is not a constant but can stretch and contract depending on gravity and speed. So if we were to manage to cross one of these wormholes, how would that affect our perception of time? Would we return to the same moment we left, or would we have traveled to a distant future? Additionally, there is the question of what would happen if a wormhole were to close while someone was crossing it. This is a chilling dilemma. Some scientists wonder if, upon entering a wormhole, one could become trapped in a quantum limbo, where time and space behave in ways we are just beginning to understand. Would this be a desirable fate or a true horror? Each new discovery in theoretical physics adds more questions than answers. The duration of an open wormhole is not only a topic of academic interest, but also touches on the essence of what it means to travel through the universe. It leads us to question our own existence and our relationship with time and space. Are we destined to be time travelers or merely passive observers of a cosmos full of mysteries? The quest for answers leads us to reflect on the nature of the universe. As we continue to investigate, will we ever be able to open a wormhole that remains open long enough to be used? Or are we doomed to keep dreaming of what could be? Science fiction has explored these themes for decades. But the reality is that so far, we are still waiting for concrete evidence that these phenomena are more than just theories. The great mystery of the duration of wormholes reminds us of how much we still have to discover. Science progresses, and each new finding may bring us a little closer to understanding these cosmic structures. But until we manage to unravel this enigma, we will continue to explore the possibilities and limits of modern physics, hoping one day to unveil the secrets of these mysterious portals in the universe. As we explore the fascinating world of wormholes, an intriguing question arises. Could there be signals indicating their presence? The idea that we might detect them through gravitational anomalies is undoubtedly a concept that piques our curiosity. But what does this really mean? Imagine a scenario where, while observing the cosmos, we notice strange behaviors in the gravity of certain locations. Could those anomalies be the trace of a wormhole hidden in the fabric of space-time? Gravity, that force that keeps us anchored to the Earth, also plays a crucial role in how we perceive the universe. When a massive object is present, its gravity can cause light to curve around it. This is known as gravitational lensing, and it is a phenomenon that astronomers use to study distant objects. Now, if wormholes truly exist, could they also create similar effects? The answer could be affirmative. If a wormhole has a structure massive enough, it could distort the light and space around it, creating anomalous patterns that scientists could detect. But how could we know if those patterns are from a wormhole or another astronomical phenomenon? This is where the ingenuity of scientists comes into play. By using advanced telescopes and cutting-edge technology, tools are being designed to study these anomalies with unprecedented precision. Can you imagine being part of a team that could discover something as extraordinary as a wormhole? The excitement of the possibility would be overwhelming. However, detection is not a straightforward process. Although wormholes could create gravitational signals, these may be subtle and difficult to distinguish from other forces in the cosmos. Could we be looking at the right signals but ignoring their meaning? The answer to this question may depend on the evolution of our technology and our understanding of physics itself. Researchers are constantly developing new methods to analyze data and search for clues that could, one day, guide them toward a monumental discovery. Moreover, it's not just about finding wormholes. The search for these anomalies could also provide valuable insights into the nature of the universe. What if, in the quest for wormholes, we also find other forms of matter or energy that we hadn't considered before? Such discoveries could revolutionize our understanding of physics and open new doors to scientific research. In this context, international collaboration is essential. Scientists from around the world are working together to share data and theories. Can you imagine a scenario where a team in one country detects an anomaly and, by sharing their findings with another team on a different continent, a connection is made that leads to the discovery of a wormhole? This synergy among researchers is vital for advancing our knowledge of the mysteries of the universe. Throughout history, we have seen how technological advancements have allowed scientists to observe the cosmos in ways that were once unimaginable. From optical telescopes to radio telescopes, each new development has expanded our horizon. With the advent of artificial intelligence and machine learning, how will these advancements change our ability to detect wormholes? The possibility that a machine could analyze data and find patterns that humans cannot see is an exciting area of research. But what happens if we find a signal that appears to be a wormhole? The scientific community would have to approach that evidence with caution. Science advances based on solid evidence, and a single signal would not be enough to declare that we have found a wormhole. This validation process is essential to maintain the integrity of scientific research. It leads us to ask, how would we distinguish between a legitimate finding and mere noise in the data as we delve into this field of study? Ethics also plays an important role. If we were to detect a wormhole, what implications would it have for humanity? The possibility of traveling through them could change our perception of time and space. But it could also raise moral dilemmas. Are we ready to face the consequences of opening such doors? These questions are crucial and must be considered as we advance in our exploration. At the end of the day, the search for wormholes is more than an academic exercise. It is a quest for knowledge and understanding. Each new discovery, whether big or small, brings us closer to unraveling the secrets of the universe. The possibility of detecting wormholes invites us to dream and question everything we think we know. Science is, at its core, the endless pursuit of answers, and each answer leads us to new questions. So, as we continue to look up at the sky, what other mysteries might be waiting for us? The story of wormholes is just one of the many adventures that modern physics offers us. With each step we take forward, we delve deeper into a universe that is vast, unknown, and undoubtedly full of surprises. The next time you gaze at the stars, think of the possibilities that might be hidden in the folds of space-time. The geometry of a wormhole is a fascinating mystery that has captured the imagination of scientists and enthusiasts alike. Have you ever wondered what the inside of one of these cosmic phenomena would actually look like? The truth is that, despite advances in physics, visualizing the internal structure of a wormhole remains a monumental challenge. We are not just talking about a physical shape, but a reality that defies our understanding of space and time. When we think of wormholes, most of us imagine a tunnel connecting 2 points in the universe, but what lies beyond that simple image? Theory suggests that its internal shape could be much more complex. Perhaps like a quantum labyrinth where the rules of classical physics do not apply. How could that be possible? In quantum physics, particles can behave in ways that defy logic, making the geometry of a wormhole even more intriguing. Let's imagine a space where the dimensions we know fold and connect in unimaginable ways. Can a wormhole have multiple exits? Could it be that by entering one we are not only traveling through space but also through different dimensions? This type of question takes us to the edge of string theory and additional dimensions. What if those paths were portals to other universes, each with its own physical laws? Einstein's general relativity tells us that gravity can curve space-time. But what does this mean for the shape of a wormhole? Some scientists have speculated that its structure could be similar to a kind of bridge, where space curves in such a way that it connects two distant points. But it could also have characteristics we cannot imagine. Are we talking about a shape resembling a tunnel, or could it be something completely different, like a sphere or an irregularly shaped object? Moreover, some suggest that the geometry of a wormhole could be influenced by the matter surrounding it. What role does energy play in shaping its form? Matter and energy are intrinsically linked concepts in modern physics, and this could influence how a wormhole behaves. Could there even be wormholes that change shape as they interact with the energy of the universe? One of the most perplexing concepts is that the geometry of a wormhole could be subject to fluctuations. Can you imagine that upon entering one, the internal shape transformed in real time? This could lead to situations where the exit is not the same as the entrance. How could we navigate through such a space, where the rules are different and logic crumbles? Some theorists have suggested that the shape of a wormhole could be affected by the presence of exotic matter, the kind we have yet to discover. But what does this really mean? Exotic matter, believed to have unusual properties, could be essential for stabilizing a wormhole. What if that matter also influenced its geometry, causing it to adopt shapes we have never seen? The interaction between gravity and geometry in a wormhole is another aspect that deserves attention. What would the space inside look like? There could be a gravitational field that distorts the perception of time and space. Crossing the threshold of a wormhole, we might experience a sense of disorientation, as if time were stretching or compressing. What would you do if you found yourself in a place where time does not flow in the same way? As we explore these ideas, we realize that wormholes could hold secrets about the very structure of the universe. Could they be keys that unlock new dimensions of reality? Each question that arises leads us to new possibilities, to new theories that are still in development. The search for answers is an infinite journey, and each discovery brings us closer to unraveling the secrets of the cosmos. The geometry of wormholes also raises questions about the nature of reality. If these phenomena exist, does it mean that our understanding of space and time is incomplete? Current theories might just be the tip of the iceberg. And each discovery in this field could lead us to rethink what we believe we know. Human curiosity is insatiable, and the desire to understand the unknown drives us to keep investigating. As we delve into the mystery of the geometry of wormholes, we cannot help but feel a mix of awe and humility. What seems to be an abstract concept may have profound implications for our understanding of the universe. What other mysteries lie hidden in the complexity of their shape? What secrets of physics do we still have left to discover? Ultimately, this exploration invites us to reflect on our position in the cosmos. Wormholes are not only fascinating from a theoretical standpoint, but they also make us question our place in the vast universe. They remind us that there is so much more to discover, that reality may be stranger than we ever imagined. Are we ready to continue unraveling these enigmas and confront the hidden truths that could change our understanding of everything? The search for answers continues, and the journey has only just begun. Have you ever wondered how the most revolutionary ideas in physics originate? One of them is the wormhole, a fascinating phenomenon of general relativity that promises to change our understanding of space and time. But what is a wormhole really, and how do we know it might exist? The theory of wormholes was first proposed by the renowned physicist Albert Einstein and his colleague Nathan Rosen in 1935. They envisioned a kind of bridge connecting two different points in space-time. But why is this idea so important? The answer lies in its potential to challenge our notion of distance and time. If wormholes are real, they could offer a way to travel instantaneously to distant places in the universe. However, there is a significant dilemma. Although general relativity predicts them, the existence of these phenomena has yet to be confirmed. As we delve into the world of theoretical physics, we find that wormholes are a mathematical solution to Einstein's equations. But what does this mean in practical terms? Essentially, these equations describe how gravity affects space and time. From them, scientists have deduced that under certain extreme conditions, wormholes could form. But are they merely a mathematical curiosity, or could they actually exist in nature? The truth is that the scientific community is divided. Some firmly believe in their existence, while others are skeptical. The lack of tangible evidence leads many to wonder if wormholes are more of an illusion than a reality. Could they simply be a product of our imagination, or is there something beyond that we have yet to discover? One of the most intriguing aspects is that despite general relativity predicting wormholes, we do not know for certain if they can form in the real universe. Current physics suggests that while they might exist, their formation would require exceptional conditions that we have never observed. So, is it possible that these tunnels in space-time are simply a fantasy created by our minds? Wormholes also raise questions about the nature of the universe itself. If they are real, what would their origin be? Some scientists suggest they could have formed in the early moments of the Big Bang, when the universe was extremely dense and hot. But if that is the key, why have we not found evidence of them until now? The answer may lie in the complexity of their formation and the instability they might present. Furthermore, the idea that wormholes are portals to other places in the universe or even to other universes raises a new series of questions. Could these tunnels be the key to traveling to parallel dimensions? The theory suggests that each wormhole could lead us to a completely different universe. However, the lack of solid evidence keeps us in a state of uncertainty. The curiosity does not end there. If wormholes are a result of general relativity, what role does quantum mechanics play in all this? Quantum mechanics suggests that particles can exist in multiple states at once, and that reality itself may be different from what we perceive. Could wormholes be a quantum manifestation, appearing and disappearing in the fabric of space-time? As we delve deeper into the topic, the question of whether wormholes can be stabilized becomes more pertinent. The theory of general relativity tells us that for a wormhole to be useful, it would have to remain open in some way. But how would that be achieved? The answer might lie in the search for exotic matter, a type of unknown matter that could provide the negative energy needed to keep a wormhole stable. However, this matter remains a mystery in itself. The enigma of the existence of wormholes leads us to reflect on our place in the cosmos. If these phenomena are a reality, what implications would that have for our understanding of the universe? The possibility that connections exist between different points of space and time challenges our fundamental beliefs about reality. Although science is advancing by leaps and bounds, the existence of wormholes remains a topic of debate. The search for concrete evidence continues, but for now, the reality of these tunnels in space-time remains in the realm of the theoretical. Are we on the brink of a discovery that will change everything we know about the universe, or are wormholes simply a distant dream? Each new finding in physics brings us one step closer to understanding these mysteries. As scientists continue to explore, the question persists: will wormholes ever cease to be a mere theory and become part of our everyday reality? The answer is yet to be discovered, but one thing is certain: the mystery of wormholes will continue to fascinate future generations. Have you ever wondered what would happen if suddenly you found yourself at the entrance of a wormhole? The curiosity about the possibility of traversing one of these mysterious phenomena of the universe leads us to an intriguing dilemma. Could we actually enter one and come out unscathed? The idea of traveling through a wormhole sounds exciting, but there is a fundamental problem. Even if they existed, the entrance could be a labyrinth from which we could never escape. Imagine stepping into a dark and unknown tunnel. How do you know if there is really an exit on the other side? The uncertainty can be terrifying. One of the most unsettling questions is, would getting trapped in a wormhole be a real possibility? Physics tells us that wormholes are unstable, which means that when attempting to traverse them, you could find yourself in a place where time and space behave in ways we cannot even imagine. In this context, the notion of time becomes blurred. What happens if, while crossing a wormhole, space twists in such a way that you become trapped in an endless cycle? This idea leads us to wonder if there is any way to safely navigate through these cosmic structures. The truth is that so far, we do not have clear answers. Quantum mechanics suggests that wormholes may appear and disappear in the void. This raises another dilemma. If a wormhole closes while you are inside, what would happen to you? Would you become part of the fabric of space-time, trapped forever in a moment you cannot comprehend? Navigating through a wormhole also raises questions about how we could control it. Would it be possible to design some kind of map to guide us through these cosmic tunnels? However, the reality is that we do not have the technology or knowledge necessary to do so. Imagine that in the end, we manage to find a wormhole that is stable enough to traverse. What about the destination? Theory suggests that we could emerge somewhere else in the universe or even in another time. But would this be a safe journey? Or would we be crossing a threshold from which we could not return? The idea of entering a wormhole evokes the image of a fearless explorer, but it also raises the dilemma of causality. If we alter the past by traveling through one of these tunnels, could we jeopardize the very existence of the universe as we know it? The question of stability applies not only to the wormhole itself, but also to the person attempting to traverse it. Could you come out the other side with your body intact? Or would gravitational forces and distortions of space-time affect you in unpredictable ways? It is fascinating to think that although wormholes could be the key to intergalactic travel and adventures beyond our imagination, they could also become deadly traps. What kind of matter would we need to keep a wormhole open and safe? The answer remains a mystery. In a world where science is advancing rapidly, it is intriguing to contemplate the idea that advanced civilizations might have found a way to use wormholes as cosmic highways. If that is true, why have we not found evidence of such intergalactic journeys? The possibility that someone has crossed a wormhole and arrived somewhere else, or even at another time, leaves us with more questions than answers. Are there other beings in the universe who have achieved what we can only imagine? As we continue to explore these mysteries, it is important to remember that, although the concept of wormholes may seem like something out of a science fiction novel, the physics behind them is real. The lingering question is whether we will ever unravel their secrets, and if we do, at what cost? As we advance in our understanding of the universe, the idea of traveling through a wormhole remains an enticing dream. But with each discovery, the need to address the dilemma of navigation arises. The possibility that it could become a one-way trip reminds us that exploring the cosmos comes with risks. So, as we look toward the stars and contemplate the vastness of the universe, the doubt persists. Will it ever be possible to traverse a wormhole? And if so, are we truly prepared to face the consequences of a journey that could change our understanding of reality forever? The search for answers continues. And with each step we take toward understanding wormholes, we get a little closer to unraveling the mysteries of the cosmos. Is it possible that there are types of matter that challenge our current understanding of physics? The idea of wormholes, those hypothetical tunnels in the fabric of space-time, poses an intriguing dilemma. How could they remain open long enough to allow the passage of a spacecraft or even humans? The answer to this question seems to be related to what is known as exotic matter. But what exactly is exotic matter? And why is it so crucial for the existence of these cosmic mysteries? Exotic matter is a concept that sounds like it's taken from a science fiction novel, unlike the matter we see and touch every day. This matter would have unusual properties such as negative energy. This might seem strange, but in the world of physics, the strange is often possible. If wormholes need this exotic matter to stabilize and resist collapse, what's the problem? The problem lies in the fact that to date, we have not found evidence that this matter exists in nature. So why is it so difficult to find exotic matter? One possible reason is that most of the matter we know, like the atoms that make up stars, planets, and even our own bodies, interacts in a way that does not allow for the existence of negative energy. Could it be that exotic matter is just a theoretical curiosity? Something we will never actually discover? The answer to this question could change our understanding of the universe. Some scientists have speculated that if we could create exotic matter artificially, we might be able to open a wormhole and use it as a shortcut through space. But how could such matter be created? There are theories suggesting that we could use advanced techniques in particle physics, but we are still far from developing the necessary technology to do so. Are we really prepared for such a discovery, or is it a fantasy too distant? Imagine a world where exotic matter is a reality. This would not only make wormholes possible, but also revolutionize our understanding of physics. We could travel to other galaxies in a matter of minutes, or even go back in time. However, every advance brings with it a series of ethical and philosophical dilemmas. Should we explore these new territories, or are there limits we should not cross? The search for exotic matter is a journey into the unknown, but it could also be a journey toward understanding our own existence. What does it mean to be human in a universe where anything is possible? If exotic matter allowed for the existence of wormholes, what implications would this have for life on Earth? Scientific curiosity often drives us to explore the unexplored, but we must also consider the consequences of our discoveries. The scientific community is divided on the existence of exotic matter. Some see it as mere speculation, while others believe it is the key to unlocking the secrets of the universe. What is your opinion on this? Science advances through debate and discussion, and exotic matter is a topic that will surely continue to generate controversy and fascination. As we delve into the realm of theoretical physics, each discovery raises new questions. If we ever find exotic matter, how could we ensure that it is not used irresponsibly? The history of science is full of examples where technology has been used for harm. Therefore, it is crucial that the search for exotic matter is conducted with caution and ethics. Wormholes are just a part of a much larger puzzle. The existence of exotic matter could open doors to new dimensions of reality. Are we ready for what we might find? Human curiosity is infinite, but we must always remember that each answer can lead to more questions. The pursuit of knowledge is an endless journey, and wormholes and exotic matter are just the beginning of a deeper mystery. Theories about exotic matter and wormholes push us to question what we think we know about the universe. Could there be other forms of life that are already using these phenomena without our knowledge? Imagining the existence of advanced civilizations that have mastered exotic matter and travel through wormholes is an idea that fascinates many. However, we must also consider the possibility that we are alone in the vast cosmos. As we continue to explore the universe, it is essential that we keep an open mind. Modern physics is based on theories that once seemed impossible. Exotic matter could be the next great breakthrough in our understanding of the cosmos, or it could just be a distant dream. However, what is clear is that the search for answers must never cease. As we reflect on the role of exotic matter in the creation and stability of wormholes, it is important to remember that science is a collective effort. Collaboration among scientists from different disciplines and openness to dialogue are essential for advancing our understanding. What discoveries await us on the horizon? The answer to that question might be closer than we imagine. What if I told you that despite decades of research and theories, we still have not found tangible evidence of wormholes? This is one of the most intriguing paradoxes in the realm of modern physics. If these structures are possible, why have we not seen any despite the vastness of the universe? The absence of evidence does not mean they do not exist, but it raises important questions about our understanding of the cosmos. Let's consider the immensity of space. There are billions of stars and planets, and within that vast backdrop, the idea that there could be cosmic bridges connecting different points in the universe is fascinating. However, the observational silence surrounding wormholes is perplexing. Is it possible that we simply do not know where to look? Or perhaps they are hidden in dimensions we have yet to perceive? The lack of direct evidence leads us to a dilemma. If they truly exist, why have we not detected them? Some scientists suggest that they could be extremely small, even invisible to our most powerful telescopes. Imagine that these wormholes are so tiny that they escape our observational capacity. Could they be present in every corner of the universe, but we simply lack the right technology to see them? Moreover, the way we perceive space-time might influence our search. What if wormholes do not behave as we expect? Perhaps their elusive nature allows them to evade our current technology. Like shadows in the twilight of the universe, they could be there but out of our reach. Einstein's theory of relativity predicted that wormholes could exist. But despite their mathematical elegance, reality remains elusive. Could it be that they are merely a product of our imagination and the complex equations we are trying to unravel? This idea leads us to question the boundary between science and fiction. Are we chasing a dream that will never materialize? As we delve deeper into this search, we find a silence that is both intriguing and unsettling. The scientific community has devoted years to studying the cosmos. And yet the echo of wormholes continues to resonate in the void. Are we truly prepared to understand what these mysteries would mean if they were ever revealed? Some theorists argue that the lack of evidence could mean that wormholes are extremely rare. Perhaps they only exist under unique cosmic conditions that we have not encountered. What would this mean for our understanding of the universe? If wormholes are so scarce, it could be that intergalactic travel is more science fiction than reality. There is also the possibility that these wormholes, if they exist, are ephemeral phenomena. What if they appear and disappear in the blink of an eye? This would further complicate our ability to detect them. The idea that a dimensional door could open for just a moment and then close forever is undoubtedly a concept that plays with our imagination. The search for wormholes is not just a matter of finding physical evidence. It also invites us to explore the limits of our understanding. This observational silence could be a reflection of our own limitations as explorers of the cosmos. It forces us to reconsider our tools and methods, and perhaps rethink how we approach the quest for truth in science. But what if, instead of searching for wormholes beyond our reach, we began to look within ourselves? Theories about the universe are ultimately a reflection of our curiosity and desire to understand the unknown. This silence could be an invitation to delve into the mystery of our own existence. The absence of evidence should not discourage us. Instead, it should inspire us to continue investigating and questioning. What new technologies might emerge in the future that would allow us to explore dimensions we currently consider unreachable? The history of science is full of unexpected discoveries, and wormholes could be one of those secrets waiting to be unearthed. In the meantime, the lack of evidence reminds us that the universe is a place full of mysteries. The search for wormholes is a reminder that, although science advances, many questions remain unanswered. Perhaps deep down, this quest for the unknown is what drives us to keep exploring, to keep dreaming. The possibility that wormholes exist, even though we have not found evidence of them, remains a beacon of hope for the curious. It invites us to open our minds and hearts to the possibility that the extraordinary may be closer than we think. On this path of exploration and discovery, every unresolved question is an opportunity to learn and grow. So, as we continue in this search, let us remember that observational silence is not an end, but a new beginning. What mysteries still await us in the vastness of the universe? With every question we ask and every answer we seek, we move one step closer to unraveling the secrets of the cosmos. The idea that wormholes could act as portals to other universes is fascinating and thought-provoking. Have you ever wondered what would happen if you had access to a parallel universe? Imagine a place where the laws of physics are different, or where history took a completely different turn. This concept is not just an exercise in imagination. Some scientific theories suggest it could be a real possibility. Wormholes, those theoretical tunnels in the fabric of space-time, have become a recurring theme in science fiction. But what if these tunnels actually connect different universes? The idea that we could traverse a wormhole and emerge in an alternate universe raises more questions than answers. What kinds of realities might be found on the other side? Some physicists, like the famous theorist Kip Thorne, have explored the possibility that wormholes not only connect different points in our own universe, but also serve as bridges to entirely distinct dimensions. But how could we know if these portals truly exist? The search for answers leads us to consider what kind of evidence we might find in the cosmos. The notion of parallel universes suggests that there are infinite versions of ourselves, living lives that vary in subtle nuances or drastic changes. What would happen if you could meet an alternative version of yourself? The idea may seem terrifying, but it is also intriguing. Such encounters could have profound implications for our understanding of identity and reality itself. However, it's not all that simple. If wormholes are indeed connections to other universes, what rules govern those interactions? Some theories suggest that crossing a wormhole could allow us to travel not only through space but also through time and destiny. This could lead to situations where decisions in one universe affect another in unforeseen ways. Are we prepared to face those consequences? The possibility that wormholes are portals to other universes also raises questions about the nature of time. In a universe where time is not linear, how would our experience of the past, present, and future be? Quantum physics has already shown us that time can behave in unexpected ways, and wormholes might be the key to unraveling these mysteries. An underlying problem is that although the theory of parallel universes is fascinating, we still lack concrete evidence of their existence. Scientists have proposed multiple models, but so far all remain speculative. Is it possible that one day we could observe one of these parallel universes? And if so, how would it change our perception of the cosmos? The questions do not stop there. Imagine we find a wormhole that clearly connects to another universe. Would we have the technology to explore it? And if we did, what kinds of beings or civilizations might we encounter on the other side? The possibility of meeting completely different forms of life presents both opportunities and risks. Moreover, the existence of wormholes as portals could mean that there are multiple versions of historical events. What would happen if we could visit a universe where certain events took an alternative path? We could see what the world would look like if certain decisions had not been made. But this also leads us to question the concept of causality. Would we alter the course of history by interacting with other realities? Philosophers and scientists have also pondered the impact this idea would have on our understanding of free will. If every decision creates an alternative universe, does that mean we are trapped in an infinite cycle of possibilities? The notion that each choice generates branches in the tree of existence is both liberating and terrifying. Additionally, exploring other universes could offer answers to some of the deepest mysteries of our own cosmos. Why do certain physical constants exist the way they do? Perhaps there are universes where those constants are different, leading to a variety of realities that bear no resemblance to our own. Could we learn from those realities? On the other hand, the possibility that wormholes are bridges to alternative universes also opens the door to speculation about the existence of advanced beings. Some theories suggest that highly developed civilizations might have learned to manipulate wormholes, using them as transportation routes between different realities. But what implications would this have for our understanding of intelligent life in the universe? In summary, the idea that wormholes could be portals to other universes is not only an intriguing topic of scientific discussion, but also invites us to reflect on our own existence. What does it mean to be human in a cosmos filled with infinite possibilities? The answers to these questions could redefine our understanding of life, time, and space. Finally, although science has yet to provide concrete evidence that wormholes connect to other universes, exploring this idea remains an exciting journey. The quest for answers takes us to unexpected places and challenges us to expand our horizons. Who knows what discoveries await us in the future? The adventure is just beginning. What is the true size of a wormhole? This is one of the most fascinating questions we ponder as we explore these mysterious tunnels in the fabric of the universe. Some scientists suggest they could be as small as a subatomic particle, while others believe they could reach dimensions large enough to allow the passage of spacecraft. But how can we imagine something so abstract and perplexing? Let's visualize a vast empty space for a moment. In this scenario, a wormhole could be like a tiny point, invisible to the naked eye, yet representing a doorway to other corners of the cosmos. Can you imagine that through a small opening you could travel to distant worlds, to completely different dimensions? However, this idea leads us to question, how big or small could they really be? If we consider current theories, it is proposed that a wormhole could be created from a distortion in space-time. But what does this imply in terms of size? Some mathematical models suggest that a wormhole could be microscopic, meaning we would need technology of an extremely advanced level to even detect it. But could we build a craft capable of traversing something so tiny? On the other hand, there are theories suggesting that these tunnels could be large enough to allow the passage of sizable objects, even spacecraft. Imagine a wormhole with a diameter equivalent to that of a mountain. This would open up a range of possibilities, such as instant intergalactic travel. But would we be able to navigate through such an immense structure without getting lost along the way? An intriguing aspect is that if wormholes are indeed structures connecting different points in the universe, we might be talking about a size that challenges our understanding. Perhaps there are wormholes so enormous that they could house entire solar systems. Can you imagine crossing a distance equivalent to millions of light years in a matter of seconds? However, this also raises questions about the stability and duration of their opening. Speaking of stability, how safe are these passages? If a wormhole were large enough to allow the passage of ships, would it be safe to cross? There are theories suggesting that wormholes could open and close in moments, making it practically impossible to plan a journey. How could we ensure that we wouldn't get trapped along the way? The idea that wormholes can vary in size also leads us to consider the possibility that different types exist. Could we find small wormholes acting as portals to other places within our own galaxy, while others, much larger, could connect us with parallel universes? This concept may seem like something out of a science fiction novel, but in the realm of theoretical physics, anything is possible. Moreover, what role does exotic matter play in the size of these wormholes? It is theorized that to keep a wormhole open, a form of matter that we have yet to discover would be required. If this exotic matter can influence the size and stability of a wormhole, could we be at a point where the size of these passages is completely unpredictable? As we explore these possibilities, we cannot help but wonder, are there wormholes right here in our observable universe? If they existed, what shapes would they take and how could they interact with our environment? Perhaps as we gaze at the vastness of the cosmos, we are looking through a window into these mysterious structures that could be closer than we think. Size can also affect our perception of time and space. If a wormhole is capable of connecting two distant points, does this mean that time would behave differently when crossing it? The idea that we could travel great distances in the blink of an eye also implies a shift in our understanding of how time works. In this context, the question of size becomes a puzzle. Each theory and model we explore leads us to new and exciting questions. Could there be a relationship between the size of a wormhole and its ability to allow time travel? Or perhaps its size determines its stability and therefore its functionality? Finally, as we reflect on the nature of the size of wormholes, it is important to remember that our current understanding of physics is just a starting point. As we advance in exploring the universe and its mysteries, it is possible that one day we will discover not only whether wormholes exist, but also what forms they may take and how they could change our way of traveling through the cosmos. So the next time you look up at the starry sky, ask yourself, what secrets lie hidden in those vast empty spaces? Could there be a wormhole waiting to be discovered, ready to take us to new dimensions and beyond? The answer may be closer than we think in a universe full of infinite possibilities. The paradox of causality is one of the most fascinating and perplexing dilemmas that arise when considering the possibility of traveling through a wormhole. What would happen if we had the ability to go back in time? The idea may sound exciting, but it also confronts us with unsettling questions. Could we change the past? And what if we did? Imagine traveling to the past and deciding to prevent a key event, something you believe would improve the future. But what if, by doing so, you trigger a series of chain reactions that alter your own existence? This is the essence of the paradox of causality, where every action has a reaction, and sometimes the consequences can be unpredictable. The history of time travel is filled with examples that illustrate this dilemma, from the famous grandfather paradox, where a time traveler could prevent their grandfather from meeting their grandmother, to science fiction stories that explore the dangers of changing the past. The idea that altering an event could undo our own existence is terrifying. Is it possible that a wormhole could allow us to travel through time while maintaining the coherence of the universe? The answer seems to be an unsolved enigma. Some scientists theorize that if wormholes do exist, they could permit time travel. But how could time and space coexist in one place without creating paradoxes? Quantum mechanics suggests that time is not as linear as we perceive it. In this context, every decision we make could open different timelines, further complicating the notion of cause and effect. When thinking about time travel through a wormhole, the idea of alternative realities also arises. If someone traveled to the past and changed an event, would they be creating a new universe instead of altering the original? This leads us to the question of whether every action we take branches into multiple realities, which would mean that the impact of our decisions could be much broader than we imagine. The narrative of time travel has also been a pillar in literature and film. Movies like Back to the Future have popularized the notion that time can be manipulated. However, these works often simplify the complexities of temporal paradoxes. Are we really ready to face the implications of altering the flow of time? The idea that every trip to the past could trigger an avalanche of consequences is unsettling, yet thrilling at the same time. A critical point to consider is the concept of the timeline. If we travel to the past and make a change, how would that affect our own timeline? Would we continue to exist in the new future we have created? Or would our existence be completely erased? These are questions that scientists and philosophers have debated for decades, and there are still no definitive answers. The possibility that our actions could undo existence itself raises questions about free will and destiny. Moreover, wormholes could also be a limited resource. If they were unstable or only existed briefly, how could we plan a trip to the past without risking getting trapped in a time loop? The idea of entering a wormhole might be tempting, but the reality of what could happen is what holds us back. The mechanics of time may be much more complicated than we can understand, and the possibility of being trapped in an endless cycle is a palpable fear. The paradox of causality also relates to another intriguing question. Could we find solutions to these dilemmas? Some theorists suggest that instead of altering the past, we might be mere observers of time, unable to change events but capable of learning from them. This would lead us to a new understanding of our place in the universe, where time would be more of a continuous flow than a linear path. The study of wormholes and time paradoxes also offers us the opportunity to reflect on our own existence. If we had the ability to travel to any moment in time, what would we choose to see? Would we risk changing something? Or would we prefer to keep the course of history as it is? These questions are not only relevant in the realm of physics, but also lead us to explore our own desires and motivations. The paradox of causality confronts us with the reality that time may not be as simple as it seems. Theories about wormholes invite us to consider time as a complex fabric where each thread is intertwined with others, creating an intricate pattern that is difficult to unravel. Are we prepared to take responsibility for our actions across time, knowing that every decision can have a significant impact on the future? In conclusion, the paradox of causality offers us a fascinating window into the mystery of wormholes and time. As we explore these ideas, we are compelled to question our beliefs about reality, destiny, and the ability to change our own past. The possibility that wormholes exist and allow us to travel through time is not only an intriguing concept, but also invites us to reflect on the meaning of our lives and the decisions we make in the present. Are we ready to face the complexities that come with the possibility of altering our own time? Is it possible that in some corner of the universe there are civilizations so advanced that they have managed to create wormholes? This idea may seem like it came out of a science fiction movie, but in reality, some scientists and theorists have explored this possibility seriously. The notion that intelligent beings might have designed these cosmic shortcuts to travel between galaxies sparks both curiosity and skepticism. How could they have done it? What kind of technology would be needed to manipulate the structure of space-time? To begin with, let's consider the enormous amount of energy required to open a wormhole. Scientists estimate that we would need a colossal amount of exotic matter, a form of matter that we have yet to identify. Imagine for a moment that a civilization might have discovered how to produce and use this matter efficiently. If this were true, could we be talking about a technology that surpasses our current understanding? Now let's analyze the purpose of creating wormholes. If an advanced civilization could build a shortcut between 2 points in space, what benefits would they gain? Perhaps they would want to explore other worlds, trade with other species, or simply travel in a faster and more efficient way. But what challenges would they face in their attempt to keep these passages open? Wormholes are not simply tunnels in space. They are complex structures that require stability. This leads us to ask, how could these civilizations ensure that their wormholes did not collapse at the moment of use? If they managed to keep them open, they would be facing a monumental dilemma. How would they balance the energy needed to sustain the wormhole with the demands of their own civilization? Moreover, if wormholes were used by advanced beings, could they have left traces of their existence? Gravitational anomalies in space could be a clue that something extraordinary is happening. But what if these wormholes were used to travel between parallel universes? This is another fascinating possibility that leads us to think about the connection between different realities. Imagine that a civilization has found a way to navigate these passages. What kind of adventures would await them? Traveling to other universes could offer them the opportunity to experience completely different realities, perhaps even encountering forms of life that challenge our imagination. But would it be safe? The idea of crossing into a parallel universe raises unsettling questions about the consequences of altering the very fabric of reality. On the other hand, there is also the troubling idea that these wormholes could be used for less benevolent purposes. What if a civilization decided to use its technology to conquer or dominate other species? The possibility that wormholes could be weapons rather than tools for exploration adds a layer of complexity to this intriguing narrative. In this context, it is worth asking whether we will ever find evidence of these advanced civilizations. If they have been able to construct wormholes, why have we not detected their presence? Could they be operating in a dimension we do not yet understand? Or perhaps they have learned to hide from us. The search for answers to these questions leads us to reflect on our own technological evolution and our place in the cosmos as we advance in our understanding of physics and cosmology. It is possible that one day we will develop our own technology to explore these mysteries. Could we also become the architects of wormholes? Imagining a future where humans are capable of navigating space and time as never before is undoubtedly exciting. However, we must not forget the moral dilemma this entails. Are we prepared to take on the responsibility of such advancements? The history of humanity is full of examples where technology has been used irresponsibly. If we ever manage to open a wormhole, how will we ensure that it is used for good? Wormholes could be the key to unraveling secrets that have been hidden for millennia. But as we contemplate these possibilities, it is essential to remain cautious. The journey into the unknown always carries risks and responsibilities. Are we ready to take them on? Finally, let us reflect on the idea that if advanced civilizations that have created wormholes truly exist, they might be watching us. Perhaps they are waiting for the right moment to give us a cosmic wink, or maybe they have already made contact, but we have been unable to recognize it. The intrigue of the unknown remains alive, and every question we pose brings us a little closer to understanding our place in this vast and mysterious universe. What makes a wormhole so intriguing? The answer may be related to its stability. Science tells us that, in theory, a wormhole could collapse almost instantaneously upon formation. But what if there are ways to keep it open? This leads us to the search for solutions on how we might navigate these mysterious tunnels of space-time. One of the most fascinating questions is there a way to stabilize a wormhole? Some physicists have proposed that we might need what is called exotic matter, a type of matter that we have yet to discover. This matter would have very strange properties, such as the ability to have negative energy. But how could we find something like that in the vast universe? The truth is, we don't know yet. However, the idea that we might need something we don't fully understand to make a wormhole work is, in itself, a captivating enigma. Imagine for a moment that we find that exotic matter. What would happen next? Some scientists believe that we could have the key to opening a wormhole and keeping it open long enough for something or someone to pass through. But what implications would this have for our understanding of space and time? The possibility of traveling through the cosmos at unimaginable speeds would change the way we think about space exploration and our place in the universe as we delve deeper into the dilemma of stability. More questions arise. If we were able to stabilize a wormhole, would it be safe to use? We could face unexpected risks. The very nature of wormholes is so strange that any attempt to manipulate them could have unpredictable consequences. Are we prepared for the dangers that could accompany such a discovery? Another intriguing question is, why haven't we found evidence of wormholes so far? Despite decades of research and theories, the observational silence persists. Some scientists suggest that even if wormholes exist, they might be extremely difficult to detect. But could they be hiding in plain sight, waiting to be discovered by the curious scientists of the future? Let's talk about the theories that explore the stability of wormholes. Some physicists have proposed mathematical models suggesting that, under certain conditions, a wormhole could be stable. However, these theories often rely on assumptions that we have yet to test. Is it possible that one day we could verify these theories and discover that wormholes are more than mere speculation? In the quest for stability, Another interesting dilemma arises. Could there be wormholes that open and close rapidly, making practical use impossible? Imagine trying to traverse a tunnel that is only open for a fleeting moment. The idea of missing the opportunity at just the right moment adds a layer of complexity to the already mysterious nature of wormholes. As we explore this enigma, it is essential to consider the impact that the existence of wormholes would have on our understanding of the universe. Would our theories about gravity and space-time change? The reality is that the existence of these phenomena could force science to rethink what we believe we know, perhaps by unraveling the mystery of wormhole stability. We will also discover new principles of physics that we have yet to imagine. On the other hand, the possibility that advanced civilizations have created wormholes as cosmic highways for traveling through the universe is a fascinating idea. If so, what technologies would these civilizations have developed to manipulate space and time at will? The existence of artificial wormholes could open up a range of possibilities for intergalactic exploration. The search for stability also leads us to think about the future of humanity. If one day we managed to stabilize a wormhole, would it be a step towards colonizing other planets? The idea that we could instantaneously travel to distant worlds is exciting. But it also raises questions about the ethical and philosophical implications of such a discovery. Are we ready to take on the responsibility of what we might find on the other side? In summary, the dilemma of wormhole stability takes us on a profound journey through modern physics and its limits. Each open question invites us to explore further, to challenge our knowledge, and to open our minds to the unknown. The search for answers has only just begun, and the possibilities are as infinite as the universe itself. As we continue to explore these mysteries, let us remember that sometimes questions are as valuable as answers. What will we discover in the future about wormholes and their place in the vast cosmos? That is a question only time can answer. As we reflect on wormholes, a fascinating question arises. Could they really be the key to uncovering the secrets of the universe? These theoretical structures, which challenge our understanding of time and space, invite us to explore unimaginable possibilities. What implications would their existence have for humanity? Would they allow us to travel to distant places in the cosmos or even to past eras? Einstein's general relativity offers us a glimpse into a world where wormholes could exist. But their nature remains an enigma. How is it possible for something so extraordinary to be at the same time so elusive? Science advances by leaps and bounds, and while we can theorize and model, the absence of tangible evidence raises profound questions. Are we trapped in a maze of possibilities, or have we simply not looked in the right direction yet? Each theory about wormholes opens a new horizon. Imagine that these portals not only connect different points in our universe, but could also be gateways to parallel dimensions. What if, by crossing one of them, we found an alternative universe where the laws of physics are completely different? The idea is as intriguing as it is terrifying, as it leads us to question our own existence and the nature of reality. The stability of wormholes is another aspect that deserves attention. How could we keep these structures open without them collapsing? The answer might lie in exotic matter, a form of matter we have yet to identify. But does this matter really exist? And if so, could we come to understand it well enough to use it in our exploration of the cosmos? These questions push us to continue investigating and to expand the boundaries of our knowledge. The time travel dilemma is also a fascinating part of this conversation. If wormholes allow us to travel back in time, could we alter historical events? Would we be able to prevent disasters, or on the contrary, cause even more chaos? Temporal paradoxes are a puzzle that scientists and philosophers have debated for centuries, and wormholes are a key piece in this intricate game. Every discovery in modern physics invites us to rethink what we know. Gravitational anomalies that could reveal the existence of wormholes are an example of how science constantly confronts the unknown. Could we at some point see signals that confirm their existence? The search for answers keeps us in a state of wonder and curiosity. The geometry of a wormhole also sparks our imagination. What would the inside of a structure that connects two points in space-time look like? The idea of traversing a tunnel that distorts reality is a difficult concept to visualize, but it invites us to think beyond our usual perceptions. Could we someday create visual representations that help us better understand these mysteries? As we advance in research, we encounter a series of dilemmas. If wormholes truly exist, how could we navigate within them without getting trapped? Would it be possible to develop technology that allows us to explore these phenomena without risks? These questions compel us to consider not only the possibility of traveling through them, but also the ethical and practical implications of such a feat. The search for wormholes also leads us to contemplate the nature of the universe itself. If these portals are real, what does that mean for our understanding of the cosmos? Perhaps we are on the brink of a new paradigm in physics, where what we once considered impossible becomes a tangible reality. The exploration of the universe is ultimately an exploration of ourselves and our place in the vast fabric of existence. As we deliberate on these issues, it is easy to be swept away by fascination. But what is the cost of advancing down this path? The pursuit of knowledge often carries risks and responsibilities. Are we prepared to face the consequences of opening doors to unknown realities? Curiosity must be accompanied by caution, and each step into the unknown should be taken carefully. Science fiction has fueled our imagination around wormholes, presenting them as pathways to extraordinary adventures. But can fiction guide us toward reality? Perhaps the stories we tell about these phenomena prepare us for future discoveries. Creativity and science are not opposed, rather they can merge to open new possibilities. Finally, as we close this chapter on wormholes, it is vital to remember that mystery is an essential part of science. Every answer we find leads us to new questions, and every discovery propels us to keep exploring. Are we ready to accept the challenge of the unknown? The search for wormholes is more than a scientific expedition. It is an invitation to expand our minds and challenge the limits of our understanding. Ultimately, the journey toward knowledge is a journey toward ourselves.